Where did everything we know come from? Where did the matter that makes up your body come from, the air you breathe, the stars that show up when you look at the sky at night? And what if the answer you think is right turns out to be completely wrong? The answer is in this video, and it's going to tear down almost everything you thought you knew about the origin of the universe. The official version goes like this. About 13.8 billion years ago, there was absolutely nothing. No space, no time, not a single particle floating anywhere. And suddenly, for some reason that no physicist can truly explain, a brutal concentration of energy appeared and exploded. Everything was born from that explosion. This story has a name. They call it the Big Bang. There are thick books written about it, Nobel Prizes awarded because of it, beautiful documentaries with dramatic soundtracks. But if you stop for a second and really think about what they're saying, you'll notice something doesn't add up. How does absolute nothingness, with no energy, no matter, no physical laws operating, just decide to explode? For something to explode, there has to be something that explodes. For a cause to exist, there has to be a moment before it. But they tell us that before the Big Bang, there wasn't even time. So how could there have been a before where anything could happen? That contradiction is unsettling. And that's why we decided to throw all this data into a machine that has no emotional attachment to any theory. We took the available cosmological models, the equations of Einstein's general relativity, the principles of quantum mechanics. We fed everything into the artificial intelligence axiom, an analytical system designed to find logical flaws in scientific and theological arguments. The task was straightforward and boiled down to this: simulate absolute nothingness and calculate the probability of a universe arising on its own from it. The result was zero, not 0 point something, a flat zero. In mathematics, zero is zero. To go from 0 to 1, you need an operation, and every operation needs something to execute it. Pure nothingness has no energy, no mechanism whatsoever to turn itself into something. Some people bring up quantum physics and say, but in the quantum world, particles appear and disappear out of nothing all the time. That does happen. Scientists call it quantum fluctuation. The argument is that the universe could have been a giant fluctuation. But every quantum fluctuation needs a quantum field to happen in, and a quantum field is already something. It functions as a complex mathematical structure with rules and predictable behaviors. Anyone who says the universe was born from nothing through quantum fluctuation is skipping a massive step. Who created the field that allowed that fluctuation? It would be like someone telling you a 100-story building built itself, and the explanation is because the lot was already there. But where did the lot come from? The data went down a different path and arrived at the first law of thermodynamics, a golden rule of physics. Energy doesn't come from nothing and doesn't vanish. It just changes form. To this day, nobody in any laboratory on the planet has managed to violate this law, not a single person. But the Big Bang theory asks for exactly that. It asks that all the energy in the universe, trillions of stars, billions of galaxies, sprouted from nothing in the first fraction of a second. The verdict came without beating around the bush. Violating this principle in a closed system is impossible. If energy appeared, the system wasn't closed. Something put that energy there from outside. Something else makes it all even stranger. Science says that time itself began at the Big Bang. Before it, there was no time. Without time, the concept of before loses all meaning. And without a before, how can a cause exist? In our world, the cause always comes before the effect. You kick the ball and then it flies. But if there was no temporal sequence, how could the Big Bang have had a cause? The analysis arrived at an answer that is elegant and uncomfortable at the same time. If the cause of the universe can't exist within time, because time was born along with the universe, then that cause exists outside of time. Time isn't some absolute thing that encompasses everything. It's a ruler that only works in here. Whoever started this process operates on a plane where time as we know it simply doesn't apply. That changes the whole conversation. If the Big Bang wasn't nothingness magically turning into everything, then what was it? The calculations point in one direction, and that direction says there was an external trigger. There was a source of energy coming from outside, and, hardest of all to swallow, there was a prior plan. The constants that govern this universe, gravity, the speed of light, the mass of the electron, appear to be calibrated with a precision that defies any explanation based on chance. And it's that calibration we're going to crack open now, because when you see the numbers up close, the idea that all of this was a coincidence becomes a joke. Think of a power plant that feeds an entire continent. You walk into the control room and see hundreds of panels, buttons, levers, blinking indicators. Each one of those controls regulates something that, if it shifts out of place, shuts everything down. And then the chief engineer looks at you with the most serious face in the world and says, nobody touched any of it, that all those buttons fell into the right position on their own after a short circuit. Out of trillions of possible combinations, it just happened to land on the only one that works. Would you believe that? With the universe, the story is similar, only on a scale that makes that power plant look like a children's toy. For decades, physicists have known that our reality rests on about 30-odd numbers that nobody can derive from any formula. They simply exist as fixed data. They are the fundamental physical constants, the mass of the electron, the speed of light, Planck's constant, the gravitational constant. These are the values that determine whether atoms form, whether stars ignite, whether molecules connect in a way that allows life. When Axiom ran thousands of simulations changing these values, what came out left us staring at the screen, not knowing what to say. Take gravity. If it were stronger by a fraction of 1 in 10 to the 40th power, stars would form too fast, burn like matchsticks, and go out in just a few million years, without giving time for anything interesting to happen. If it were weaker by the same proportion, matter would have scattered like fine dust without ever clumping enough to ignite a single star. Without stars, no planets form, and without planets, we wouldn't exist. The adjustment is so tight you can compare it like this. It's like hitting a coin at the other end of the observable universe, blindfolded, on the first shot. And gravity is just one of the controls. The balance between the strong nuclear force, which glues protons and neutrons together inside the atom, and the electromagnetic force, which tries to push them apart, is even tighter. If the strong nuclear force were 2% different, no element heavier than hydrogen would have formed. Carbon, oxygen, iron, none of them would have appeared. The universe would be an eternal soup of gas. And if that constant shifted 0.1% the other way, all the hydrogen would have burned in the first instance, and stars like the sun would never have existed. There's a piece of data that, when we first read it, seemed like an exaggeration. The density of the universe in the first microsecond had to be calibrated to an accuracy of 1 part in 10 to the 60th power. 60 zeros after the decimal point. Denser by that fraction, and everything would have collapsed back on itself. Less dense by the same margin, and the expansion would have been so violent that no galaxy would have formed. When astrophysicists come face to face with these numbers, they're floored. They themselves call it the fine-tuning problem of the universe. The word tuning already gives it away, because tuning is something someone does. To escape that conclusion, the materialist camp invented the multiverse hypothesis. The idea is that trillions of other universes would exist with different constants, and most of them would be unviable. We simply hit the cosmic jackpot of being in the only one that worked. It's a clever way out, I'll give them that. Except there isn't a single piece of observable evidence of another universe. No telescope, no particle accelerator, no instrument ever built has detected the slightest trace of a parallel reality. The analysis discarded this hypothesis using Occam's razor, which basically says that when you need to invent infinite invisible things to explain one visible thing, your explanation is probably wrong. The cleanest explanation, the one left standing after cutting away everything that doesn't hold up, is that the constants weren't formed by chance. They were set. Anyone who's ever programmed anything in their life, even an Excel spreadsheet, I mean, maybe Excel is a stretch, but anyone who's ever built any kind of logic on a computer knows that the first thing you do is declare your variables. You define the values that are going to govern the system's behavior before you hit play. The mass of the electron, the charge of the proton, the speed of light. They are rigid values that were in place before anything started moving. They were chosen with a precision that goes far beyond what luck can explain. This universe was set up to generate life. The parameters were tuned for it from the very first instant. But if we accept that we live inside a mathematically designed structure, where the laws of physics work like fixed rules written in advance, a question arises that goes deeper. What is the fabric of this structure made of? Every construction, when you look closely enough, reveals the material it's made from. And when we go down to the deepest level of reality, to the boundary where space and time stop being continuous and start breaking into pieces, what shows up down there changes everything all over again. When we watch a river flowing or a leaf falling from a tree, the brain understands it as continuous movement, as if the world were made of one smooth, unbroken mass. It feels like any piece of space can be split in half forever. That feeling is so natural that nobody questions it. But when you go deep enough into matter, past the atoms, past the protons, all the way to the absolute limit of what can exist, that continuity shatters. There's a boundary. Physicists know it by the name Planck length. It's a measurement so ridiculously small that you can't even compare it to anything in normal life, but I'll try. Take an atom, which is already something that fits by the billions inside a drop of water. Now imagine that atom grew to the size of the entire universe, from end to end. At that blown-up scale, the Planck length would be roughly the size of a tree here on Earth. That minimum size is all that space allows. Below it, distance doesn't make sense. There's no such thing as half a Planck length, just like there's no such thing as half a step on a staircase that only has full steps. And the same thing happens with time. There's a minimum interval called Planck time, which is the time it takes light to cross one Planck length, something around 5.4 times 10 to the negative 44th power of a second. Nothing in the universe can happen faster than that. It's the smallest possible tick. Reality doesn't flow like a river, it advances in jumps, frame by frame, at an insanely high but finite frequency. Axiom processed this data and reached a straightforward conclusion. Space has grain and time has rhythm, and both have limits. That alone already messes up a lot of what we learn in school. But when you cross this information with quantum mechanics, the penny drops and the floor goes with it. There's an experiment that has been repeated hundreds of times in laboratories all over the world since the early 1920s, and every time someone repeats it, the result is the same mind-bending thing. It's the double-slit experiment. It works like this. You have a wall with two narrow openings and a screen behind it. You fire electrons, one at a time, at the wall. Logic says each electron will pass through one slit or the other and leave two marks on the screen, one behind each slit. Simple. But when you turn on the screen and look at the result, instead of two strips, an interference pattern appears. That pattern of alternating bands that should only happen if a wave passed through both slits at the same time. A single electron, fired on its own, behaves as if it went through both paths simultaneously. It exists in all possibilities at once as long as nobody is measuring, what physics calls quantum superposition. The scientists thought, let's install detectors at the slits to catch which one the electron actually goes through, and when they did that, the pattern changed instantly. The bands vanished. The electron started behaving like a regular little ball, hitting the screen in two predictable strips. The moment someone tried to observe its path, the particle dropped its wave behavior and became solid matter, as if it knew it was being watched. In 2012, a team from the University of Vienna took it further by firing entire molecules of fullerenes, balls made of 60 carbon atoms, and the same effect appeared. When nobody was measuring, waves. The moment measurement happened, particles. The size of the object didn't matter, and what mattered was whether or not there was observation. There's an even more unsettling version called the delayed choice quantum eraser, carried out in 2007 at the Munich Institute of Quantum Optics. The scientists managed to erase the information about the electron's path after it had already gone through the slits, and when the information was erased, the interference pattern came back. The particle seemed to rewrite its own past based on a decision made in the present. I mean, seemed is an understatement. The data shows exactly that. It's just that our brains resist accepting it. Matter doesn't exist in a defined state until something interacts with it. As long as there's no observation, what exists is a cloud of probabilities. Only at the moment of measurement does reality become concrete. The world isn't just sitting there, solid and ready, waiting to be seen. It defines itself in the act of being seen. Einstein hated this idea. He once asked in frustration whether the moon ceases to exist when nobody's looking at it. But 90 years of experiments after his question, the data always points in the same direction. And if space has grain, time has rhythm, and matter only takes shape when it's observed, then what exactly is time? The next piece fits in a way nobody expected. We treat time as if it was something obvious, like breathing. It's there, always has been, always will be, pushing everything forward. Clocks measure it, calendars organize it, the mirror shows it. But when physicists went to pop the hood on the universe to understand where this feeling comes from, that everything moves in only one direction, from past to future with no reverse gear, they ran into something disconcerting. The fundamental equations of physics, the ones written by Newton, by Maxwell, by Schrödinger, don't distinguish past from future. If you film 2 billiard balls colliding and run the video backward, both versions obey the same laws. At the level of atoms, time can run in either direction. The formulas work just the same. So why do things in our world only move forward? Why does a cup that falls on the floor and smashes never reassemble itself and hop back onto the table? Why does smoke rising from a campfire never go back into the wood? This problem has a name among physicists, the arrow of time paradox, and it has tormented entire generations of people far more intelligent than us. The answer that axiom extracted from the data points to a single culprit, the second law of thermodynamics. This law says that in any closed system, entropy only increases. Entropy is, in very plain terms, the amount of disorder. Think of a perfect sandcastle on the beach. Millions of grains organized into a beautiful structure with towers, walls, windows. Leave it there for 2 days under the wind, the rain and the tide. It'll turn into a shapeless mound. Order broke down. Entropy went up. And this is the only law of physics that works in one direction only. Every time something happens in the universe, a star burns hydrogen, a cell divides, you take a breath, the total disorder of the system goes up a little. It's this constant accumulation that creates the illusion that time moves forward. Time doesn't exist on its own. It works like the trail entropy leaves as it grows. If entropy stopped, time would stop with it. If entropy reversed, time would run backward. The arrow of time follows the arrow of entropy. Then the tone gets darker. If entropy only increases, if disorder only grows, then the universe is inevitably heading toward a state of maximum disorder. Astrophysicists have calculated how it ends. Trillions of years from now, the last stars will exhaust their fuel and go out. Galaxies will scatter into darkness. Black holes will slowly evaporate. In the end, all that will remain is a frozen soup of subatomic particles at a temperature close to absolute zero. Nothing else can happen. Energy has spread so evenly that there's no longer any potential difference to generate any event. They call it heat death. What this idea produces, when you accept what we've been building up to this point, is a clear picture. Entropy works like a countdown clock, embedded in the structure of the universe. Nobody put it there by accident. It works as a guaranteed shutdown mechanism. If someone designed this, that someone wanted the process to end on its own, without needing outside intervention to shut it off. But while everything in the universe obeys this law of decay, while stars die, mountains erode, and galaxies fall apart, on a little blue rock lost in the corner of an unremarkable galaxy, something completely insane happened. Matter organized itself. Instead of heading toward chaos like everything else, it began building increasingly complex structures. From simple molecules to long ones, then to chains that replicate, that became cells, that became organisms, that one day looked up at the sky and asked where they came from. This is called life. And life, from the standpoint of thermodynamics, is a scandal, because life takes energy from outside and uses it to create local order. It decreases entropy around itself temporarily at the cost of increasing entropy somewhere else. It's like inside a building that's collapsing floor by floor. Someone on the 3rd floor is building a new apartment, using the bricks falling from the 5th. Okay, the comparison is a bit rough, but that's the idea. The direction is opposite to the natural flow of the universe, and conventional science says this happened by accident. That molecules in a primitive ocean 4 billion years ago were shaken by lightning and ultraviolet radiation until by sheer luck they assembled into the right configuration to become the first living cell. When you turn that story into numbers, as we're about to see, luck becomes a mathematical absurdity, so glaring that the word chance loses all meaning. Let's get to the numbers, because this is where the conversation goes to a whole different level. The building blocks of life are proteins. A protein is a chain of amino acids fitted together in a specific order. In nature, there are hundreds of types of amino acids, but life uses only 20. To assemble one of the simplest functional proteins, you need about 150 of these amino acids in the exact sequence. Get one wrong, and the protein doesn't work. It's like a combination lock with 150 digits, where each position has 20 possible options. You spin the wheel 150 times in a row and need to get every single one right. Axiom calculated the probability of one of these proteins assembling itself. The number is 1 in 10 to the 164th power. To put that in perspective, in the entire universe there are only 10 to the 80th power elementary particles, protons, neutrons, and electrons combined. If the entire universe were made of chemical soup, and that soup stirred trillions of times per second for 13 billion years, there still wouldn't be enough time to assemble even a single functional protein by chance. And a cell needs hundreds of them working together. But the protein is just the part. The complete blueprint is in the DNA. Every cell in your body carries a molecule with 3.2 billion base pairs, written in a 4-letter alphabet: adenine, guanine, cytosine, and thymine. It's a volume of information so dense that in a single gram of DNA, you can fit 215 million gigabytes. No human technology has come close to that level of miniaturization. And here's a knot that conventional biology does everything it can to avoid facing. On its own, DNA does nothing. It only serves as an instruction manual. To read that manual and build what's described in it, the cell needs molecular machines made of proteins, ribosomes, enzymes, an entire miniature factory. But the recipe for building those machines is written inside the DNA. So the DNA needs the proteins to be read, and the proteins need the DNA to be built. Who came first? In computing, this kind of deadlock is called a bootstrap. The machine won't boot without the program, but the program won't run without the machine. And the only known way to solve a bootstrap is for someone from outside to install the first package manually. By the way, there's another detail that almost nobody talks about. The cell itself spends a staggering amount of energy preventing mutations. There are enzymes that patrol the DNA around the clock, scanning error by error, cutting out damaged sections and pasting the correct version back in. If evolution depended on random mutations to advance, why does the cell do everything in its power to prevent them from happening? It's as if the organism came with factory-installed antivirus software, protecting the original code against unauthorized changes. The verdict is blunt. Life did not arise from random chemical accumulation in a primitive ocean. The cell had to show up ready, with the manual and the factory running at the same time. That raises a question that's genuinely uncomfortable. If someone designed this code and set it running on this planet, why only on this planet? When we look at the sky at night, there are hundreds of billions of stars in the Milky Way alone, and the Milky Way is one among 200 billion galaxies. By the sheer math of probability, the Drake equation suggests we should be surrounded by intelligent civilizations. They should be sending signals, building detectable structures, colonizing neighboring systems. But when we aim our best radio telescopes at space, the silence is total. No signal, no trace. Scientists call this silence the Fermi paradox. Where is everybody? The analysis rejected the hypothesis that we're alone by accident. Among so many trillions of planets, the chance of life appearing only on Earth through natural means is zero. If we don't see anyone, there is a deliberate reason for it. The speed of light, for example. 186,000 miles per second sounds like a lot, but on the scale of the cosmos, it's ridiculously slow. To reach the nearest star to Earth, Alpha Centauri, 4.3 light-years away, traveling at the speed of light would take over 4 years. To cross our galaxy, 100,000 years. That limit exists like a fence, and space outside of Earth is lethal. High-energy cosmic radiation, micrometeorites, vacuum. Our DNA, so sophisticated and so fragile at the same time, doesn't survive out there without protection we still can't build. We're trapped. On a planet that's perfect for us, surrounded by a universe that kills us if we try to leave. And as beautiful as the galaxies we see through the telescope may be, the question that lingers is whether what we're seeing is all that really exists out there, or if there's something we can't see holding this entire structure in place. Science talks a lot about what it can see: stars, planets, nebulae, galaxies. But what astronomers don't like to admit in public is that all of it, absolutely everything we can detect with any instrument ever invented, accounts for only 5% of the total mass of the universe. 5. The other 95% is a complete mystery. They know it's there because gravity gives it away, but they can't see it, touch it, or measure it directly. To plug that hole in the math, they came up with 2 names: dark matter and dark energy. Pretty names for saying we have no idea what this is. The problem started showing up in the early 20th century, when astronomers noticed that galaxies spin too fast. The rotation speed is so high that centrifugal force should rip every galaxy apart, send the stars flying in every direction like water spraying out of a sprinkler. But they stay together. Something invisible is holding everything in place, and the mass of the visible stars isn't enough to explain that gravitational glue. Dark matter, whatever it is, accounts for about 27% of the universe's mass, and dark energy, which is the force making the universe expand faster and faster, accounts for the other 68%. Axiom processed the most detailed gravitational maps in existence and reached a reading that changes the entire framing. Instead of some exotic particle that physicists keep hunting for in accelerators, dark matter may simply be the gravity produced by other structures that exist on the same substrate as our universe, but that we can't access. Other environments running in parallel, with their own physical constants, sharing the same foundation. Most of these environments may be dead, stillborn from combinations of constants that didn't produce stable matter. They just sit there taking up space, exerting gravity but without light, without chemistry, without anything our telescopes can pick up. And dark energy? The accelerating expansion of the universe might simply be the consequence of more and more information being generated. As processes keep running, as entropy grows and life keeps generating branches of possibilities, the volume of data increases and space needs to stretch to accommodate it. Galaxies moving away from each other faster and faster would be the visible effect of something we can't see, the continuous growth of the whole thing. If this universe was designed by someone, if the evidence points in that direction from the very first calibrated constant all the way to DNA that can't be random, then whoever designed it should have left a mark. Every creator does. Artists sign paintings in corners that almost nobody looks at, and architects carve initials into the masonry as if to say, "This was me." And when you look for that signature on the largest painting there is, in the depths of the sky, in the first glow the universe ever emitted, something appears that astrophysics cannot explain. The cosmic microwave background is the oldest light in the universe, emitted when the cosmos was only 380,000 years old and had cooled enough to release the first photons. This radiation is everywhere, at a temperature of about 2.7 degrees above absolute zero, so faint that for decades nobody had the equipment to map it properly. Until the satellites came, COBE in 1992, WMAP in 2003, and Planck in 2013. And what they found in the maps made a lot of people uncomfortable. First, a gigantic cold spot simply dubbed the cold spot, a region where the temperature is inexplicably lower than the rest. The size of this anomaly is so large that no conventional theory can account for it. Second, and this is what kept serious cosmologists up at night, the temperature variations that should be completely random and distributed equally in all directions are organized along a specific axis that cuts through the universe from end to end. Scientists themselves nicknamed this structure the axis of evil because it contradicts everything the standard model predicts, and the detail that makes it all click. This axis is aligned with Earth's orbit around the Sun. The chance of that being a coincidence is about 1 in 10,000. Why would the oldest thermal structure of the universe, formed billions of years before our planet existed, be pointing here? Why does this heat map, that should be chaotic and indifferent to our existence, seem centered on us? When this data was analyzed, not as thermal residue from an explosion, but as a structured sequence of information, what emerged were binary patterns, regular alternations between hot and cold that form a logic. A signature written in the oldest light there is, waiting to be read by whoever developed the technology to see it. A signature only has value when someone can read it. And to read this one, the species living on this little blue rock needed 13 billion years of a functioning universe, 4 billion years of biological evolution, roughly 10,000 years of civilization, and in the final stretch, a few decades of satellites sophisticated enough to measure variations of thousandths of a degree in the depths of the sky. If this was planned, whoever planned it knew it was going to take a while, and had patience. Axiom took all of it, every anomaly, every number that doesn't add up, every pattern that shouldn't be there, and tried to build a profile of who did this. Not a religious profile, not a figure with a white beard sitting on a cloud. A technical profile, cold, based on the characteristics of the project itself. What came out goes roughly like this. Whoever designed this thinks like an engineer. Every decision we find has economy, has logic, has optimization. Space is granular because infinite processing doesn't exist. Time, same story, it emerges as a byproduct of entropy, since every process needs a deadline. And the speed of light, finite, because range needs a limit. And life? It showed up with built-in error correction, protecting the original code against noise. Nothing in there is wasted, nothing in there is decorative, bare-bones engineering, no frills. And why would someone with that level of capability build something like this? The analysis considered billions of scenarios and converged on a hypothesis with an extremely high confidence margin. Whoever created us is facing a problem they can't solve alone. It could be the heat death of their own reality. It could be a collapse that our concepts don't even have a word for. What we know is that simulations on this scale aren't built for fun. They're built when the answer you need is too dangerous, too slow, or too complex to be pursued in the real world. You build a sealed laboratory and let the experiment run. We are that experiment. 8 billion human brains, each consuming the energy of a 20-watt light bulb, yet capable of something no known circuit can replicate. Instead of working like a calculator, the brain makes leaps, creates connections between things that have no obvious relationship, generates new information from nothing visible. It feels empathy for strangers, creates music that gives you chills for no logical reason, solves problems during sleep. An Indian mathematician named Ramanujan, born in 1887 to a poor family in Madras, would write down formulas that professional mathematics took decades to prove. When asked where they came from, he said they appeared in dreams. Nikola Tesla would visualize entire machines working inside his head before drawing a single line on paper. The brain does things it can't even explain how it figured out. No classical algorithm operates like that. And if the architect needed a tool capable of generating the unexpected, he built the right one. If that's our purpose, if we were designed to generate solutions that the intelligence of our creator alone can't reach, then the question, where did all of this come from, gets an answer that closes a full circle. The matter that makes up your body, the air you breathe, the stars that appear when you look at the sky, all of it came from someone who needed us as much as we wonder about them. There is no universe without an observer. Quantum mechanics made that clear. And perhaps there is no architect without the beings he designed to think what he cannot. There's a beautiful irony there, if you stop to notice it. Entropy's clock keeps ticking. Stars keep burning fuel. Space keeps stretching. The deadline exists and it doesn't negotiate. But as long as those 8 billion brains keep generating ideas, connections, questions nobody has asked before, the experiment is still worth running. The day humanity stops thinking, stops creating, stops questioning, That's when the experiment loses its meaning. And maybe that's the real meaning of heat death. Not because the energy ran out, but because curiosity died first. When we started this conversation, the question was simple. Where did everything come from? And the answer, after taking every piece apart and looking at what's inside, isn't a name, isn't a face, isn't a religion. The answer came in the form of a realization. This was put together on purpose. It was calibrated, it was written, it was signed. And whoever did it is waiting to see what we do with the time we have left. If you liked this investigation, subscribing to the channel helps us expand the Axiom investigation project. We would love to read your thoughts on the video subject in the comments and your suggestion for the next topic to be covered. Tell us which city you are watching from. Thank you for staying with us until the end.